Hello and welcome, my dear students, to today's revision session, especially for grade 11 advanced math for your coming term 1 exam. On the onset of this session, I wish you all the very best for your coming math exam. In today's session, we are going to revise from your exam coverage EOT vehicle some FRQ questions which I feel are important for the coming grade 11 math exam. This is Ms. Ruchika and I welcome you to today's revision video. Let's get started with the FRQ questions. Okay, so let's solve the first question from the FRQ. Here we have to evaluate expressions involving the natural base and natural logarithm. These are questions 13 to 15 on page 237 to 38. So the question is on compound interest. Let's highlight the important information. So the sum of money that this person Rian is investing is $5,000. This is your principal amount. And the keyword here is continuously. So this is a question on continuous compounding formula. Let me write the formula for you. So the formula is amount is equal to principal multiplied with e to the power rt. Okay, A is my amount, P is my principal, R is my rate of interest, and T is my time. Now the rate of interest, annual rate, is given to be 2.5%. Whenever you are using the value of R, it has to be in decimal, so we will convert. So it is 2.5 divided by 100. You move the decimal on the left, so this becomes 0.025. Okay, and after this we look at the time. So time, let's see what is written. So write the function that represents the situation where A is the value of Rian's investment after T years. So T is not given, we will take it as it is. Let's put everything in this formula. Principal is $5,000. T we don't know, we will keep it as it is. And then E as it is. R is the decimal 0.025 and T. So this is the answer for part A. Now there's another part to this question, so let's move on the next slide and see what we have to do it there. This is an expression with two unknown variables A and T, so we can't really simplify it. We have to continue and move on to part B of the question. So this is part B. In part B, the same values are given to you. The only difference here, the time is mentioned. So we are going to put in place of T 7 years. This is the time. So let's write the formula again. So from part A, we had got this answer, the amount. I'm putting all the values as we did. And now we are just going to replace the T value. So T, in place of T, I'm going to put 7. So open your calculator, solve this calculation, multiply 0.025 with 7. So if you simplify this and put everything in your calculator, it will come out to be $5956.23. So what amount this person Rian is going to get? So after 7 years, Rian's investment will be worth $5956.23. Now let me tell you one important thing, that how you will know that this is a question on continuous compounding. You will see this keyword word continuous, and that's when you need to know that you have to apply the formula A equal to P e to the power RT. Please learn this formula because there are a lot of questions in your FRQ EOT exam coverage on this formula. Let's do some more questions and move forward to question 14. Okay, so this is question 14. It is of the same kind, same type. The only difference is in the numbers. So let's highlight the important information. My principal is $6,500. My annual rate of interest is 3.25%. So when you convert this to decimal, your R value will come out to be 0.0325. Okay, the keyword again is continuous, so I'm going to use the same formula, A equal to P e to the power RT. In this part, you have to just leave your T as it is, so plug in the other numbers that you have here. Always remember that your rate in the formula has to be in decimals and not percentage. So this is going to be my answer to part A. Let's move to part B. So in part B, the time is given to you. It is 18 years. So I'm going to use the formula that we got from the first part and plug in place of t the value 18. So e to the power 0.0325 times t. So let's put t as 18. I put in the value. Use your calculator, substitute and simplify, and this amount will come out to be $11,667.44. So the answer to part B finally would be that after 18 years,
توجه من الأستاذ
Jiraiya
محمود السماطري والأستاذة أنورة
investment
الحضور للإدارة. The coordinators of science, please come to the admin.
will be worth $11,667.44. So that completes question 14. Let's move on to question 15 now. Okay, so if you read question 15 properly, it is exactly of the same kind with different numbers. That's why I put the solution for you to check. This is the amount which is the principal. This is the rate of interest. Converting to decimal, it will be 0.055. In part A of the question, t is not given, so we will use the same formula. The keyword here again is continuous, and this is going to be the answer. For part B again, we are given the time. T is going to be 9 years. So in place of T, we replace the answer for part A with T equal to 9. Plug in, substitute, solve, use your calculator and simplify. So after 9 years, Marcela's investment will be worth $20,000, 916.35. Okay, so let's move on further to the next question. Okay, so the next question is on solving problems involving exponential growth in TK. It's a long question. We are going to again highlight the important information and then use the formula for continuous exponential growth to solve it. So let's go. In year 2000, the world population was estimated to be 6.124 billion people, and in 2005, it was 6.515 billion. Okay, so these all values are given. In part A, we need to write an exponential growth equation to represent the population y in billion t years after 2000. So therefore, there are going to be two variables, y, which is representing the population after t years. So y and t we have to retain as it is. Let's write the other variables. Now I will explain this equation quickly in case you have forgotten. Y is representing here in this question the population. A is the initial population. So initially we begin with the year 2000. So we are going to take our value of A, which is the initial population, as 6.124 billions. Then the time t is not yet given to us, but yes, it is also given to us that t for year 2000 was 6.515. So if I take my time to be 2005 minus 2000, it's going to be 5 years. Okay, and during this time, what was the population? It was 6.515. So I'm going to use that information, plug in my formula. Again, you have to learn this formula, it's important, and put y as 6.515. So let's go. 6.515 in place of y. A is 6.124. E will be as it is. K I don't know yet, but yes, the time I have calculated to be 5. Now what is going to happen from this equation? The only unknown that I don't know is K. So let's go and find K. For that I have to remove this number. So I'll divide both sides with the same number, 6.124. Take out your calculators, divide them, and tell me what you get. So this is going to be, let's do it on the calculator. So the fraction 6.515 divided by the fraction 6.124, these two decimals are going to land up in 1.0638. Okay, and then this one gets cancelled, so e to the power 5k. Now I need my k. So always remember, if you have an exponential equation, this is an exponential equation because it has e, and you have the variable which is unknown that you need to find in the power, then you always take log of both sides. Now because it is e, I will take natural log ln. Had it been 10 or a common log, I would have taken log. Remember that. So ln e 5k. And what happens when we take this ln is that ln e is already 1. Or if it was any other number as well, like ln e x equal to x, then this ln e becoming 1, the only thing which will be left on the right side would be 5k. So 5k is going to be equal to this log. Again, put it back in your calculator and then divide both sides by 5 as well, because I want just the k, so I'm going to remove the 5 from both sides. So again, use your calculator and this whole part comes out to be around 0.01238. So this is an approximate value because it's a long decimal. This 5 cancels definitely. So this part of the question, part A, gives me the value of k, or the rate of growth. Now this value you have got approximately as a decimal, so I would like to convert it to a percentage. So for that we multiply with 100. So the decimal shifts by 2 places, 1, 2, so it's going to be 1.238%. And because it's an approximate value, I can't put equal to. So this is an approximate value. Now let's go back to this part and let's plug in this value in this first equation, because it is asking me to write an exponential growth equation, and this is my exponential growth equation which I started the question off with. So now I'm going to come back and put the values back again here. Initial was 6.124 e to the power, we have the value of k now, so 0.01238, that's my decimal, and t. So this is the final answer for part A. Now there's another part to this, part B, so I'm going to do that on the next slide. So concluding part A here, the population of the world t years after 2000 can be modeled by this equation. The final answer, y equal to 6.124 e to the power 0.01238t. Let's proceed to part B now. Okay, so now for this part B, we are going to use the equation we got from part A. So let me write that equation first for you, and then we will see what all variables and values are given. So y is equal to 6.124 e to the power 0.01238t. Okay. So in year 2000, the world population was estimated to be this much. In 2005, this all we have used. So we are now using directly the equation, which was the answer for part A, this one. And here now we have to predict in which year the world population will reach 7.5 billion. So what do you think? Y is given or T is given? We need to find actually the year. So T is what we need to find and Y is what is given. Yes, you're right. So let's plug in 7.5 and then try to find our t from here. Now notice that the t is in the power, so we have to bring it down. So we'll divide both sides with 6.124, cancel this, and then again use our calculator to simplify. Because your t is in the power and we want it to be coming down, so we will take natural log of both sides, just like we did in one of the previous questions. So this is going to land up with me with ln e 0.01238t. Now you know ln e is 1, so the only thing which is left on the right side is the decimal multiplied by t. And if you use your calculator and get the log value, eventually we have to divide it with this decimal because we don't want this decimal on both sides. So the whole thing, this side also gets divided with 0.01238. So this value will come out to be approximately 16.372, which is the value of your t. Now the number of years can't be decimal, so approximately we would round off and say that the world population will reach 7.5 billion people approximately after 16 years. So that's going to be year 2016, because they ask in which year the population will reach 7.5. So we can say the population will reach 7.5 in 2016. Okay. Okay, let's do the next question on consumer awareness. I will read for you as usual and highlight the important information. Jason wants to buy a new HD television, but he thinks that if he waits, the quality of the HD televisions will improve. The television he wants to buy costs $2,500, and based on the pricing trends, Jason thinks that the price will increase 4% each year. In part A, we have to write an exponential growth equation to represent the price y of a new HD television t years from now. So let's write the equation y equal to a e to the power kt. This is the equation. It's a growth equation. Exponential growth is given. So I'll put in the values. I'll plug in what is given here. So if you see carefully, the value which is given initially is $2,500. So I will put that value e to the power kt. K we don't know, t we know. Yes. Sorry, k we know. K is actually 4% given. So I'm going to convert it to decimal as usual. So this is going to be divided by 100, 0.04. So I will now replace here the value of k, which is 0.04, and multiply with t. T is not mentioned, so the first part of the question just asks you for the exponential growth equation. So we can model the price of the new HD television t years from now by this using this equation. Let's move to part B and see what the question is asking there. I will move to the next slide. Okay, so let's solve part B of the question. In this question, we will be using the equation that we got from the first part. So I will write it down again. And in this part B, it is asking you use the equation to predict when a new HD television will cost $3,000. That means the value is given to you, but we need to find the time after which it reaches this value. So T is what we need to find. So let's plug in the values. 0.04 t. Now I need t, so I'm going to divide both sides with 2500 and get rid of this value. So what are we left with? E to the power 0.04 t, and if you simplify this fraction, it will come out to be 1.2 decimal. Now similarly, like the previous question, I need my t, which is in the power. So in order to apply power rule and property of equality for logarithmic equation, I know ln e is 1, so I'm going to use that and take natural log on both sides. When I do that, the right side leads me to the decimal and the value of t, and on the left I have the natural log. You can go ahead, use your calculator now, divide both sides with this decimal so that we get rid of it, and your t will approximately come out to be 4.6 years. And if we rounded this off, then we can say that the new HD television will cost about $3,000 because this decimal here is, the first decimal place is more than 5. So we can say after 5 years, the new HD television will cost $3,000. That completes this question. Moving on, let's go to the next free response question and see how we solve it. So let's solve part C. In this part, Jason decides to wait to buy a new television and saves his money. He puts $2,200 in a savings account with 4.7 annual interest rate compounded continuously. Determine when the amount in his savings will exceed the cost of a new television. So we will use previous parts A and B also, and exceed means more than. So therefore, there will be a greater than inequality in this question, and we will again use the formula for exponential growth. So from previous parts, we have got this formula. I will rewrite again. And for this new television, there's a different principle, there is a different rate. So let's apply the same equation, y equal to a e to the power kt for this part. So the amount is 2200, e to the power kt, k here is the value 4.7%, convert to decimal, it will be 0.047 t. So I want to know the t value at which this becomes greater. So what we will do, we want t which is in the power, so definitely we will take natural log ln of both sides. So what happens when we do that, there are two different logs. If you see this thing, 2200 is multiplied to this part, similarly 2500 is multiplied to this part. So I'm going to go ahead and use property of inequality for logarithm, and we will break this one logarithm which is multiplied into two parts. So ln 2200 plus ln e to the power 0.047 t is going to be greater than, again break, ln 2500 plus ln e to the power 0.04 t. So which is this property? This is the product property of logarithms which I use, where the multiplication changes to addition. Now I can combine the like terms and take them together. So I'm going to move this ln on the other side, and I'm going to move this value on the other side. So when I do that, what happens? Let's see. ln 2500 minus ln 2200. Why minus? Because the sign changes for this log. From positive it becomes negative when going on the right. Now before I do this moving for the next term, I know already that my ln e is 1. So what is left here? 0.047t minus 0.04t. Subtract. This is going to give us 0.007t, which is more than the difference of this log. So in next step, I want my t, so I'm going to divide with this decimal on both sides. And my t is going to be more than, use your calculator, simplify, 18.3. So what does that tell you? So we wanted to say, determine when the amount in the savings will exceed the cost of the new television. So after 18 years, 18.3 precisely, the amount in Jason saving will surpass the cost of a new HD television. So as you can see, now we've completed the whole question, part A, part B, part C. So part C was a little different in the sense, here we had an exponential inequality. Okay, so the next question is on exponential decay. How do you know that? You read the keyword. It asks for equation of decay, and it also asks you for the value of k. Okay, so let's solve this question. Now for this question, if you see, there are some things which are already mentioned to you. For example, the radioactive substance has a half-life of 32 years. So what is this 32 years? It's basically T half. Means the time period or the number of years in which the substance reduces to half the quantity. So for example, if a substance is initially say A amount, this is the initial amount. Then after half-life, it will be reduced to half. So A divided by 2, or we can convert to decimal also, so 0.5A. Is it fine? So let's use this, and I'm going to use this time the equation for decay. So the only difference will be in sign. The sign will be negative, and this is called as the formula for continuous exponential decay. I will write here and put a star mark, means you have to learn it, remember it, and use it while you solve the problem for FRQ. Now remember, for FRQ you have to show all your steps, all your working. So do it as much in detail as you can, because all steps are carrying marks. Okay, so this is the formula. Now we will put the values. We know because it is half-life of 32 years, only half of the amount will be left. So it will be 0.5 times A is equal to A e to the power kt. Now T is given to you as, in fact it is T half, radioactive half-life 32. So I will put that value, and k I don't know. So let's find k. For that we will cancel few things. A will cancel on both sides. So 0.5 is going to be equal to minus 32k e to the power this. Now I can take log of both sides, same logic. I take natural log, reason being I want my k value, so this will come down in the next step. So minus 32k is left, and I divide both sides with minus 32 so that I could get rid of this extra value, and I can get my k from here. So how much is k? Now you can plug in everything in your calculator. This part will simplify, and it will approximately give you a value of 0.02166. So if I convert this to percentage, I'm going to multiply with 100, and my rate of decay or percentage of decay will come out to be approximately equal to 2.166%. This is per year, okay? So that completes part A. Let's move to part B in the next slide. So in part B, we use part A. I think you would have understood by now, doing all the long word problems that we have been doing since the beginning of this video. and the beginning of this session that the parts are interconnected. So I'll be using this equation from part A. Now what is part B asking? How much of a 5-gram sample of a radioactive substance should be left after 100 years? So how much is your T? It is 100 years. How much is your initial amount? The one that you begin with, it's 5 grams. So I will just plug in these two values here and let's see what we get. So 5 e to the power minus 0.2166 multiplied by t. So put all the numbers, simplify, use your calculator, and this value will come out to be approximately 0.57 grams. So how much is left? We started with 5 gram, but after 100 years only about, why I say about, because it's approximate, I don't know the exact value, approx or about 0.5 grams of the radioactive substance should be left after 100 years.